question of finding out how the body responds to a long period in this environment. Could you give me 2 or 3 examples of research in this area that you are going to be involved with on this flight?
Now we are beginning a study or experiment that is geared to evaluate brain activity of humans. We have studied it on the ground, and we have a lot of methods on studying the human brain, how brain processes are sped up or slowed down. But now we are trying to study these detailed processes, very fine processes regarding the neurological system of the human body and how it influences the physical activity of the humans. We are studying this research on board the station, and they're not very easy, especially on Earth. And now we have the methods, we have the means, and we're beginning to work on this research. Chris Cassidy, our colleague, will be involved in this research, in this experiment, and he will be the man who will be measuring different parameters, different characteristics of the human brain activity. The second experiment will be about the vascular system of the human body, and we would like to know the dynamics of the changes in the human body. I think it is a very important area and requires some really fine research. And the third area, we will need to provide and to support our crews in good physical shape in long-duration missions, and to develop special physical exercises. And I should say that the USOS segment has great equipment that allows for training human body and training every part of the human body, and we would like to study the degrading effects of the zero-G on the muscular system. And we will try to find ways to slow down the process, to support the human body in zero-G for 2 or 3 years. And we understand that the methods that we have been using or used before, when each crew member had to spend an hour and a half to support his physical shape, is not the most optimal. It's not very efficient as far as crew members' activity goes, because we basically take out 2 hours out of their workday to just provide their safe return. Now we have quite good equipment, exercise equipment, or biostimulants that can actually stimulate the muscles of very different muscle groups and support the human body. So now we want to find the ways to maintain a human body in a good physical shape. We need to learn how to live in space.
And that's those are good examples of the kinds of things you're doing in that area. There are also other areas of science that you'll be working on in portions of your days and weeks as well. Give me a couple of examples of science in other disciplines that you're looking forward to working on during this mission.
You know, in my first space flight, when I was on Mir station, we had a very unique experiment, plasma crystal. And it began as a fundamental study of physics of cold plasma. And we came to the conclusion that it produced a lot of results. The study of the plasma crystal is actually a study of how different structures of weak cold plasma react to the space environment, to 0G, and how tiny particles in the plasma interact with each other. And we call it a plasmic crystal because these little particles form a certain frame in the crystal, and it's surprising. And we would like to conclude this experiment that began in 1998. We did not cease to study it, but now we have new equipment, and I think that we were going to have a new item for this research in the nearest future. We do not just push a button and turn the equipment on, but we can actually manipulate the state of this plasma, and each crew member is capable of influencing it and to see on the screens what structures our actions and manipulations produce. It's just a phenomenal study. It answers so many questions that we didn't have answers to. How those particles and structures react to the 0G and the vacuum. And vacuum is very complicated. This is one of the examples. Another unique experiment is actually about the study of new materials that we can produce in the 0G environment. And I'm talking here about the alloys that we are not capable of producing on the ground. And of course, there will be a number of experiments that answer the questions on how the outer field around the station works. We have never studied it before. It's such a great man-made structure at the height of 280 miles from the ground that is actually influenced by different fields and magnetic fields that we have not studied before. So I think that exploring deep space without the study of what is going on around the station are not feasible. And it's going to be a very important step in creating new spacecrafts that will allow for this deep space exploration. So, of course, we need different registering equipment, sophisticated equipment, and of course there will be an experiment on laser communication devices. We have actually carried out a few tests, and this laser comm will be very beneficial and gives phenomenal results in space.
These are very interesting examples of a range of different kinds of things that you will be doing inside the station. But there's also, in the plan now, the opportunity for you to do work on the outside of the station. Now, I know that plans can change, but I'm interested to hear what is the current plan for spacewalks for the crew members during the Expedition 35 and 36 time.
Ну, да, вот наш план, наши планы выходов, они как бы такие достаточно динамичные.
A few EVs, and the plans are very dynamic and can be changed. And I think it is due to the increase of the tasks that we have to perform. It's not because of us not knowing and not being capable of doing something. We are trying to get as much as we can from the spacewalks. Of course, we're going to have a spacewalk with Roman Romanenko, and it's going to be for the installation of special sensors and antennas that show the state of the electromagnetic field around the station, not only around the RSOS. Another task is going to be the installation of equipment necessary to dock, targeting to dock ATV-4. Because with ATV-2 and ATV-3 we had a few negative moments and few problems because of the measuring channels and the target. So now we'll try to resolve it. And we will also expose a number of new materials to the space environment, because not all of the materials pass the test of this space environment. They're fine on the ground, but not there, and they're going to install special trays with these new materials. Also, we're going to study biomaterials. They have been in space for almost a year, maybe even longer. So the Institute of the IBMP, Institute of Medical and Biological Problems, has been conducting this study for almost a year, and they discovered that despite the radiation and vacuum, some organisms are capable of staying alive in space. And our scientists revealed that some bacteria are capable of surviving in such harsh environments. And we are going to remove one of such trays. And our further spacewalks, we are planning 5 spacewalks all in all. They're going to be about operations to dock the new module, the MLM module. We will have to provide power lines and to transition the power lines from the USOS to the RSOS, and it's not a short route, to attach them, to lay the cables for data transfer as well, and to install data trusses, data buses. And of course we're going to be installing scientific equipment on the outer shell of the station. I think that we are going to install 2 telescopes that will be tracking the Earth's surface and also other astronomical bodies. These telescopes are produced in Canada, and all in all, the plans are very extensive, and it's a new period, it's a new leap in the increase of the scientific potential of the station. And we are very excited about it.
That's a lot of different kinds of things that you're going to do, and you're going to make some of these spacewalks yourself, right?
That's right.
Но вот совершенно однозначно мы с
I am sure that I will have the spacewalk with Roman Romanenko.
Второй, по-моему, выход.
I think it's EVA 32.
Дальше, наверное, это будет, конечно,
And
Александр Мисюркин,
Alexander Misurkin,
Федор Юрчихин.
Fyodor